My name is Savannah Lennon, and these are the Week 11 readings from edX for Physics 2211. So, the main physics ideas that were expressed in this week's videos were the concepts of modeling friction, the conservation of momentum, collisions in one direction, so head-on collisions, and then collisions in more than one direction, so glancing collisions. And the bottom line with the glancing collisions is that we can apply the momentum conservation principle to each spatial direction, meaning like X and Y, the components of the system. So new information this week for me were collisions, because I have never learned that before. And I also learned that contact is not necessary for a collision to occur, like in the case of a proton and an electron. And the key features of collisions are that they are strong interactions over a brief time interval. And previously learned information were that of energy, momentum, and friction, and also Newton's second law. So some formulas that we were given in these lectures were, well, some of them aren't really formulas, but we were told that if the final kinetic energy does not equal the initial kinetic energy, then you have an inelastic collision. And this could represent a change in thermal energy. It just means that since there's been energy loss, there must be somewhere else where the energy is non-zero to make up for it, so that F net is always equal to 0. And then they also told us that if delta K is equal to 0, then you have an inelastic collision. And to determine if a collision is elastic or inelastic, you should compute the initial kinetic energy, the final kinetic energy, find the change between the two, and then if it's equal to 0, you have elastic. If it's not, it's inelastic. And then we have Newton's second law for multi-particle systems, or the conservation of momentum, which ended up being F net is equal to all of the net forces from the surroundings acting on the system. And this is a really, really good starting point to solve any of the collision problems. My curiosity was that I found it really interesting that when you were applying the momentum principle, so Newton's second law, to a multi-particle system, if you compute the net force, all of the forces that are exerted by one force onto another in the system can be paired up. So like the force of mass 1 on mass 3 and the force of mass 3 on mass 1 are like reciprocal. And then by reciprocity, these pairs of forces cancel out. So this ultimately means that the total net force is equal to only all of the external forces acting on the system. And this doesn't relate to the neuroscience field, but I did find it really interesting that you can basically ignore all the forces internally in the system and only focus on the external forces. And this is actually what leads you to the conservation of momentum in the case where there are no external forces, because momentum will be conserved. And that's also why momentum is conserved in the universe, because ultimately there's no external force acting on the universe itself, so all of the momentum within it is conserved. The most confusing topic for me was that of the glancing collisions, but after rewatching the video, I was able to piece together that you really just have to break the question down into the components of the system and then apply the multi-particle momentum principle, so just like the sum of all the external net forces on each direction of the system. And then I didn't really use any of the supplemental resources because the videos did a thorough job, and most of the material was just an extension of what we've previously learned this semester.